Alright, welcome to this session of binary operations. We're going to elucidate everything that you need to know on binary operations and the expected questions that you should find in exam papers. So, let's start by defining what a binary operation is. So, a binary operation is simply a relation in between elements of a given set of numbers. So, in a binary operation, you will be given a binary operation. They will give it to you. And then they're going to ask you about like 4 or 5 questions that will always be asked. Number one, you proven if the given binary operation is a true binary operation on a given set of numbers. Okay, so they'll give you an operation, then they'll ask you to say, all right, is this operation true on a set of even numbers? Is this binary operation true on a set of integers, on a set of natural numbers, and all the likes? That's the first question that you should expect. The second question is it associative? Is it commutative? Second question, or that's third question, kind of comes in at the same. They can either ask you together or in separate questions. And then they'll also tell you to evaluate something. Yeah, they'll give you something, and then they'll tell you to say, okay, evaluate this. So those are like the main questions that you must always expect on a binary operation. So let's cover those 4 to 5 questions. I don't know how many there were. I wasn't counting. So let's start by the first one that said, proving if a binary operation is true on a set of the given numbers. Alright, so first things first, you must be familiar with all different types of numbers that we have. You must know real numbers and you must know imaginary numbers. Okay, so you must know integers, you must know natural numbers, you must know prime numbers, you must know odd numbers. So all those numbers must be in your head. You must know whole numbers. If I said whole numbers, I think I haven't said whole numbers. So all those numbers should be in your head. Alright, so let's say I give you a binary operation that says a star b is equal to a plus b. Okay, so is this binary operation true on a set of real numbers? Now they won't ask it in the way that I'm saying it. They are going to say, is star a binary operation on a set of let's say natural numbers. Okay, so let me start with natural numbers. So on the same question I can ask natural numbers, on the same question I can ask integers, on the same question I can ask whole numbers and anything that I think of. Okay, so let's start with that one there. So is star a binary operation on a set of natural numbers? So what I'm going to do is this. I'm going to get two natural numbers, and then I'm going to put them inside my binary operation and see if the answer is going to give me a natural number. If it always does give me a natural number, then yes, my star is a binary operation on a set of natural numbers. So on my own, I'm going to say, okay, let a be equal to 1 and let b be equal to 2. So I'm going to say 1 star 2 because 1 is taking the position of a, 2 is taking the position of b. So this is going to be 1 plus 2. This is going to give me what? 3. Is 3 a natural number? Yes. Was 1 and 2 natural number? Yes. So there we've proved. How about in a case where I change this binary operation and say, okay, now let me make this binary operation like this. Let me say, I rub it, the dang it, stubborn. Alright, so let me now change my binary operation to a star b is equal to a minus b. Okay, I'm still trying to see if this binary operation is true on a set of natural numbers now. Okay, so I put a minus b. So I'm going to keep my same numbers, 1 and 2, because 1 and 2 are natural numbers, and I'm trying to see if this binary operation is true on a set of natural numbers. So I'm going to say, okay, sorry, not a. Let me just change it to 1 representing a, 2 representing b. So it's going to be 1 star 2 is equals to 1 minus 2. So this is going to be negative 1. Is negative 1 a natural number? No, it isn't. Negative 1 is an integer, a negative integer to be more specific. Natural numbers, remember, start from 1 and go all the way to positive infinity. 1, 2, 3, 4, and they go all the way this side. So negative 1 is not a natural number. Therefore, this star is not a binary operation on a set of natural numbers. Okay, so it's just basically as easy as that. So let's get more complicated by getting a wide range of numbers. So let me just scrap that off. Okay, so now let me say what? Let me say let me get a binary operation that says a star b is equal to maybe 2a plus maybe 3b. Okay, and then I say, is this binary, is star a binary operation on a set of even numbers? Okay, on a set of even numbers. Now here I've gotten really specific. So what do? I think, what are even numbers? Okay, and then I think, what are the simplest even numbers that I can have? So I can have 2 and 4, right? So I can say, okay, let a be equal to 2, let b be equal to 4. So this is going to be 2a, so this is going to be 2 star 4 is equal to 2, uh let me say 2 star 4 here. 2a is represented by 2, and then b is represented by 4. So it's going to be 4 plus this times that, that's what, 12, huh? So if you add these two, it's going to give you what, 4 plus 12, that should be 16. Is 16 an even number? Yes, it is. So right here you can simply say that this star is actually a binary operation on a set of even numbers. So I can also think of complex even numbers, but I'm sure they should give me the same still. So if I say maybe 10 and 12, okay, so let me try out 10 and 12. So the key thing here is that the answer should always give you the same thing, 10 and 12. So I'm going to say, let my a be equal to 10, let my b be equal to 12. So it's going to be 10 star 12 will be equal to 2 10 plus 3 12. So it's going to be 20 plus 36. So it's going to give me 56. Is 56 an even number? Yes, it is. And therefore, I have proved that whatever even numbers that I'm going to pick, my answer will always come out an even number in this binary operation. So yes, this binary operation is true on a set of even numbers. So basically, as simple as that. That's what you should expect under these type of questions, okay? And then sometimes it can make it really difficult for you guys, where they add exponentials. Yeah, they add to my powers, Jay. Let's have one where they're going to add powers. So they can have it like this. Alright, they can choose to have it like this. They say a star b is equal to 2 to the power b minus a. I can have something like that. Okay. In fact, I don't even need to put it like that. Let me just say, okay, a star b is equals to a to the power b. As simple as that. I can have it as simple as that. So this is going to be what? Remember, let's say I'm trying to prove if this star is a binary operation on a set of real numbers. Okay, real numbers. So I'm going to get two real numbers. And if my answer gives me a real number, then yes, this star is a binary operation on a set of real numbers. But if it doesn't, then no. So here's what I'm going to say. So picking two simple real numbers, I can say, okay, let me pick 1 and 2. Okay, so this simply means that a will be equal to 1 and b will be equal to 2. All right, so here is it's going to give me 1 star 2 is equal to 1 to the power 2. 1 to the power 2 is what? 1. Is 1 a real number? Yes, it is. So therefore, this is true. This is very, very true. Now, you should be careful when it comes to proving this part, because yes, these two numbers that you picked have given you something correct, but there are also other real numbers that we'll pick that won't give us a real number. What I'm talking about? You picked 1 and 2 and they gave you an answer that's a real number, but there are also other real numbers that can be picked that won't give you a real number. So let me say I pick negative b, negative b, negative b, wait, negative b, negative b. Okay, no. Let me do this. Let me say for a, let me pick negative 4, and then for b, let me pick 1 over 2. So both of these are real numbers. So here's what I'm going to say. Negative 4 star 1 over 2 is equal to negative 4, yes, and then to the power 1 over 2. So since it's to the power 1 over 2, it's going to come as a square root. It's going to be square root of negative 4. The answer here won't give us a real number. It's going to give us 2i, and 2i is an imaginary number. Okay, so here you see that not all of the real numbers that you get will give you a real number in this binary operation. Therefore, this star is not a binary operation on a set of real numbers. So what does this then entail us about all those other binary operations? So as you see a binary operation, you're supposed to be able to analyze the situation. Are there any set of numbers that they have given me that can give me something that doesn't belong to that set of numbers? Okay, so here I asked about real numbers. So are there any real numbers that will give you something that isn't real? You must be able to think critically and think fast, because yes, you must pick the easiest numbers for you to calculate, but you must also pick the right simple numbers. So you're supposed to be able to have that power of analyzation as you are having your binary operation. So key thing is having exposure to this, knowing what type of binary operations and what specific in what specific sets, like what numbers you should be picking. So just answer a ton of questions on binary operations, and you should be familiar with what numbers to pick and when to pick them. Yeah, so that was the first round. That was the first bout of this solving.